because it's going to be a little while before we use them again. So it wouldn't be the worst thing in the world for you to try just on your own to write them down once again. So writing down the prefixes for 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10, because we're going to come back to them, but not until next week. So take this as a chance to do some spaced repetition, get yourself a piece of paper, or you can write them on the cover of your workbook, okay? Which might be a good place to do it. Yes. No, it's okay. Okay, what is 1? Mono. 2 is di. 3 is tri. 4, tetra. 5, penta, like a pentagon. 6, hexa. And remember, 6 has an X in it, and hexa also has an X in it. That might help you to remember. And both 6 and 7 both start with the letter H. Okay, and it is hepta. All right, that one's a little tricky, but give it a go. 8 is octa. 9 is nona. And 10 is deca. And what's funny about mono? What do we do with mono that's different from everybody else? Yeah, we leave mono off the first word, but put it on the second, okay? And there's a couple of letters that we drop. What are the 2 letters that we drop? A and O. And we only do it in front of oxygen, oxide. Okay, so when you are doing these prefixes, what do we use the prefixes for? What kinds of compounds? Covalent compounds. And you can tell that you have a covalent compound because it is made of a nonmetal and nonmetal. And that's the only time you use prefixes, is with those covalent compounds. So like I said, unless you're getting caught up on quiz 2 needs prefixes. And quiz 3, some have prefixes and some don't, because some are ionic and some are covalent. But quizzes 4 and 5 have nothing to do with prefixes because they're all types of ionic compounds. So we won't see those again until next week. Okay, so we're just reviewing those so you don't forget them over the weekend. All right. So those are our prefix, and those go on covalent only. Now, we also learned something else yesterday. What did we learn about yesterday? we learned about the Roman numerals. And what kind of elements need Roman numerals? Red zone metals, yes. So red zone metals need Roman numerals. What do Roman numerals tell us? What happened? Come back. They tell us the charge. Of the metal. So quiz number 4, some of you have done quiz number 4 already. A lot of you have not because it wasn't required to do until today. Quiz number 4, some will need Roman numerals and some will not. Okay, so I'll just put up quiz 4 here. I won't put up any names until after today because most people haven't yet done it. But this is some Roman numerals. And some not. Okay. So that's what we're aiming for today, is to get through quiz 4. But before we do that, we are also going to learn a little something extra so that people who have finished quiz 4 can successfully move on to the next section if they want to. Okay. So let's see what we've got here. We want to be on page 33. Now, we're not going to go through all of this today, but we're just going to go through it enough to give you a flavor. And actually, I need to also give you a chart with polyatomic ions on it. So in addition to your periodic table, we have a table of polyatomic ions. 1, 2, 3, 4, 5. And we'll say this is your green sheet. Okay. That's going to make it easy for you to find. All right. Okay, so this is on page 33. So we've already, in the last unit, we're introduced to polyatomic ions. And so in a polyatomic ion, we have 2 or more atoms, and they are actually, because it is a non-metal, Oxygen is a nonmetal. And nitrogen is a second nonmetal. What kind of bond? Those are covalent bonds. But when we have a covalently bonded polyatomic ion, it actually becomes part of an ionic compound, which is kind of strange. Okay, but you can have both covalent bonding and ionic bonding in the same thing. Okay, so here we have covalent bonding within the molecule. And because it is an ion, we have put the charge on the outside. And you can see in this, we have N, we have O, and there, how many O's do we have? 3. And so we write this NO3 minus. And remember, negative means -1. Okay? And I would like you to look on your green sheet and see if you can find NO3 minus. Do I not have it here? Oh my gosh, that's crazy. That's okay. I will go back to here because I'm sure I have it here. No? What? Okay, that's crazy. Let's try that one. Okay. Where is it? Why do I have it nowhere? This is driving me bananas. I went past it? No, it's okay. I have something very similar. That's okay. I'll go to my Chem 11. I know I've got it in Chem 11. That's fine. It'll be a little bit different than yours, okay? Because in the Chem 11 one, they are organized alphabetically, but they're organized alphabetically by the name. Yours has it alphabetically both by name and by formula. So if you're looking for NO3, you would look at the bottom of your chart. This is really irritating. I want to have it up here. But you would look down on the bottom of your chart where it says alphabetically by formula. And you'll go down to where it says NO3 minus, and you'll see that it is named nitrate. Okay, so you'll notice on this sheet, what do most of the names end in? Just take a look through and tell your partner, what do most of the names end in? A lot of them end in 8, and then a few of them end in eight. Okay, so there's 8s, and then there are some 8s, 8, 8, 8, and there are 2 that are ides. Okay, and that'll come in important if you decide to do the enriched stuff and learn how to name acids. That will matter a lot. But for now, the names are just what they are. Another thing I'd like you to notice is that down here we have some ors. Or. So if you see an ion that is HCO3 minus, you can either call it hydrogen carbonate or you can call it bicarbonate, and it doesn't matter which one. Okay, so you get to choose. CH3COO minus, you can either call it acetate or ethanoate. Both of those are correct names. Acetate is the common name. Ethanoate is the official name. Okay? And anytime you write a quiz or a test, you will have both your periodic table with the red zone and you will have this list of ions. Okay? All right, let's go back to our class. All right. Can't believe I don't have that here, but that's okay. Here we go. All right. Just like any other ion, polyatomic ions get their charge because they have gained or lost electrons. You don't need to worry about this, okay? But if I was to look at my valence electrons, or actually if I was to look at my total protons, nitrogen in NH4, nitrogen has 7 protons. Hydrogen has 4 times 1 is 4 protons, and 7 plus 4 equals 11. Yeah? But for nitrogen, we have 2 core electrons in nitrogen, and then in the valence shells, we have 2, 4, 6, 8 from nitrogen and hydrogen together. So we only have 10 electrons. So there's actually 1 more proton than there is electron, and that's what gives it the positive charge. If you followed that at all, that's excellent, but it's not something you're required to know, and there won't be any questions on it even in the enriched section. Okay? So don't worry about it if that didn't make sense. Now, let's remember compounds are neutral. What does it mean if they're neutral? That means their charge is 0. So if I have a compound made of Mg, magnesium, and if we go to our periodic table, we will see that magnesium is in group 2, and therefore its charge is plus 2. Okay, so magnesium is here, and it is 2+. Nitrate, we were just told, back up here, that it has a -1 charge. And so if we want our compound to be neutral, we need to have not 1 nitrate, but we need to have 2 nitrates. All right, that'll give us a total of 2-. Okay, and that gives us 2- and 2+ gives us an overall neutral charge. How we write the formula for that is we have 1 Mg, so we just write Mg, and I'm not going to try the G because it's a funny typewritten G. And then we put NO3 in brackets, and we put the 2 on the outside. That tells us we've got 2 of that entire ion. I have 1 of the NO3s, and I have 2 of the NO3s. Is good? Okay. Let's meet a few polyatomic ions. We're not going to look at all of them, but here are a few. Ammonium is NH4+, and it is one of only 2 positive polyatomic ions that is commonly used. Okay, so if we look on here, you can see up in our positive ions on your green sheet, over on the left is ammonium, and that's NH4+. If you listen to the last name, ammonium, it's got that ium ending. Can you think of any other elements that end in ium? calcium, sodium, calcium, sodium, lithium, barium, aluminum, okay, or at least close. And if you're, yeah. So what do calcium, sodium, lithium, barium, and calcium, sodium, potassium, lithium, strontium, barium, cesium, rubidium, radium, francium, scandium, lutetium, lawrencium, yttrium, aluminum. What do they all have in common? They are all what type of element? They are all metals. And what charge do metals take on? Positive. And what charge is ammonium? Positive. So that -em ending tells you that it's going to be a positive ion, okay? Not all metals end in -em. There's, I don't know, gold, iron, but a lot of them end in -em. So here's ammonium. It is NH4. What kind of bond is there between the N and the H? What kind of bond is that? Covalent. N is a nonmetal, H is a nonmetal. Nonmetal, nonmetal, therefore that is a covalent bond. So that's a ball and stick model. That is a space filling model. And where I'm going to show you a crystal lattice of ammonium chloride. So we have ammonium, which is positive, and chloride, which is negative. Ammonium, which is positive, chloride, negative, and so on, and so on, and so on. Yes? What kind of bond is happening in between the ammonium and the chloride? What kind of bond is that? That is an ionic bond. Okay, so between the two ions is an ionic bond. And that is ammonium chloride. Ammonium has 1 nitrogen. It has 4 hydrogens. So its formula is NH4. And ammonium, let's look up the charge of ammonium on your sheet, or actually it's right up here, isn't it? Ammonium is positive. What is the charge of chloride? Chloride is in group 17. So its charge is -1, okay? So we have ammonium and we have chloride. Do those charges equal out to 0? A +1 and a -1? Yes. So our formula just needs 1 NH4 and 1 Cl. And you'll notice I did not put brackets around the NH4. You only put brackets around if you have more than one of that polyatomic ion. Okay? No brackets. All right. Here, I had fun doing this. I actually literally cut and paste these by hand. So there's little ammoniums. That's your NH4. And that's another NH4. And then here we have these red ones. These are oxide Oxide is in group 16. What is the charge of oxide? -2. So we have O2 minus. That means if we have NH4 plus and we have O2 minus, do those equal out to 0? If I have +1 and -2, does that equal 0? No. So what we will do is we will add a second NH4. That gives us 2 NH4s. And when we add those together, we get 2 plus. And so to show that we have 2 NH4s, we'll write NH4 in brackets. And then outside, we will write a 2. And that shows us that we have 2 NH4s. And then we only have 1 O, so we just write O. Okay? So when you're naming these compounds, you would just look at it and you would say, I have this NH4 at the beginning. I just name it ammonium. Yeah? And then I go and I'm saying, like, what else do I have? I've got O. O is for oxygen, but it's the second element, so it has to be oxide. That second ending always changes to ide. All right. Here is acetate. That one's pretty fancy, yes? And I often have people ask me, why don't we just write it as C2H3O2? Because you could, right? There's 2 carbons, 3 hydrogens, 2 oxygens. And the fact of the matter is that you can write it that way. However, look at the structure. What do we have over on this side? We have C with 3 H's, so CH3. And then over on the other side, we have COO. Okay, and if you go on to study some organic chemistry, that COO little group is a famous group. It's got its own name. It's called a carboxylate group, and it has certain properties. It makes it a base, and that's fairly exciting. So that's why we write it like that, because it actually shows the little special group, the COO group, that gives it its properties. But if you were to write it as C2H3O2 minus, that is also correct. Okay? Here is sodium acetate. Sodium, group 1 is +1. Acetates, CH3COO minus. Do those charges cancel each other out? Yes, we have a +1 and a -1. So all we need is 1 sodium. And you'll notice there's no number there, so it's just 1. And there's also no number beside the acetate, so that's just 1 as well. 1 sodium, 1 acetate. Sometimes these formulas can look kind of scary. Like if I didn't tell you this was sodium acetate, you might look at this thing and be like, ah, so many letters. So many letters. Where do I start? Where do I stop? What's happening? The good news is you'll only ever have to name 2 ions. Okay? You're never going to have 1, 2, 3 things. You'll only ever have 2 things. If you find your metal, then everything else goes together. Okay, so you're like, okay, I got sodium. After sodium, I'm gonna write down sodium, and then I'm gonna say I've got so many letters, CH3COO. But don't panic, because you can go to your polyatomic ion table and you can look up acetate. Does that make sense? Okay, and you can look it up on your find it by alphabetical by formula. okay, in the C section. Some other acetate compounds, we have calcium acetate, and in this case, you'll notice because Ca is 2+, we need 2 of the acetates, and that 2 goes on the outside of the brackets. We have iron 3, and remember that 3 means that the charge is 3, not that there's 3 irons. So we have Fe3+, which means we need -1 and -1 and -1 to equal up to -3 to give us a neutral compound. And so we have a 3 on the outside. Silver, just +1. So we just need 1 of the acetates, -1. And so we get AgCH3COO. And you'll notice no brackets. Because there's just 1. Would it be okay to write CaCH3COO2? No. What that 2 would do is it would say, I only have 2 of this oxygen. I've got 1 of these, and 1 of these, and 3 of these, and 1 of these, where I should actually have 2 of these because the bracket says there's 2. This one, the bracket says there's 2. The bracket says there's 2. The bracket says 2 times 3 is 6 of those. Yeah? And the 2 says there are 2 of those as well. Okay? So if you have more than one of a polyatomic ion, it has to have brackets around it. If you have just one, no brackets. All right? And I feel like I have talked enough for today, and it would be really good if you guys could make sure by the end of today you have finished quiz 4. Or if you're getting caught up, you might get caught up to quiz 3. You know, let's not try and kill ourselves getting there. If you've already finished quiz 4, you can feel free to either do the review, pages 28 to 32, or if you're like, that's boring, you can work on reading through the rest of the polyatomic ions, and then you can answer the questions on pages 40, 41. So that's if you are finished quiz 4. Okay? And for the rest of you, make sure you finish quiz 4. If you haven't finished quiz 1, 2, 3, or the prefixes quiz, or if you want to redo any of them, that's what you're going to start with. So start here. And I'm going to hand back quizzes. And I actually have your tests as well, which is in today. 22. Okay, so we got 10 minutes-ish. Okay. So, why don't I grab, let's see. I'd like to do quiz 2. These are all covalent, so they will all be with the prefixes. And you have those written down, do you? Yeah, okay, so you can use this if you want to. All right, and so if you have one of them, you'll put one. If you have two of them, you'll write die. And then remember, if you have, I'm just gonna mark it down for you. First word. Yes.
It's just like quiz 1A and B that you both are.
So you'll do quiz 1A. Okay, and then you'll do quiz 2A. Now this one is all ionic complements. So those ones, no prefixes. Quiz 2, covalent compounds, those ones you will use. Okay. And do you have a list for you? On your internet? Yeah, and if you want to use them, you can. Okay.
I have the prefix question.
Yes.
They do it all?
You did it, and you got, I think you got 10 out of 10. Let me just double check. Mono, di, tri, tetrafeta, hexapentanon, deca, 10. Yes.
Like all of them?
Huh?
I did all of the
You may have done all of the quizzes, and if you finished all the quizzes, you can start reviewing. I will also give you your quizzes back in case you want to redo any of them, okay?
I did. So if my name's not there, I did it.
That means you did it.
I just don't remember doing it. Alright.
Okay, well, let me double check for you. Carson. Oh yeah, quiz 3. Sorry. Carson.
Yeah.
Oopsie.
I'm like,
Thank you for checking.
no, I'm like, I didn't even know.
You're
what
like,
it
I
was
did
on.
not do that.
Wait, what even is it on?
So,
And some-
It is, some of them are ionic,
Okay.
so some of them will have metals, so there will be no prefixes. And then some of them will have just
So-
2 non-metals, and so these ones will use prefixes.
Okay, so if there is one metal, then I wouldn't.
No
do it.
prefixes.
Okay.
Yeah.
So did I get this?
Yes, do you know where to find them?
Yes.
Yes, perfect. Hi. You did the prefix quiz. How come I don't have it written down?
I did the second one.
You did the second one.
I had an issue.
Okay, did it look like this?
It was on like.
Was it on like an actual like piece of paper with questions on it? That's different. All you need to do for this one is write down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and write down the prefixes, and then you're done. Okay? On any piece of paper you want.
Where do I get the prefix quiz?
The prefix quiz is literally just like a piece of paper. Let me grab one for you.
It was like look for Li. So you find lithium. So you write lithium, and you make the resistance fluoride. You get rid of also
Okay.
I don't know.
Where's my scissors? Where do my scissors always go? I always lose them. There they are. Really bad at keeping track of things. Okay, here we go. Here we go. So you just write your name, and you write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you write all the prefixes on there. Okay? Let's get those quizzes all back. Hello.
Yeah, quizzes.
The ones to give back.
Yeah, like.
Yes, I'm just looking for where I put my bag so I can
Wait,
put them
are you
back.
gonna give the unit test?
I just have to find it.
And then in the middle is just names on it. You get
I'm just gonna pop to the prep room because I think I left your quizzes in there.
I just have to next this page and then look at page. Dave's the only part of college that oh yeah. How the name had I say some of them are some People think that I film her as well.
Oh my gosh, I'm so silly. Hi.
So, are we allowed to use this sheet on the quiz?
Yes.
Oh, okay, okay.
Okay.
And how do we know if this is false fate or false fight? Because it just said that,
PO4,
yeah.
PO3.
But for other ones, like 4, like is like item. So it just
You just have to look it up.
Oh, okay.
Okay. Thank you very much. All right. So when you hear your name called, I've got a quiz to get back to you. Logan, Carson, Armando is not here. Thank you, Davey. Asma, Kimmy, Jerry. I'll hold you for you, Asma, okay? Thank you. Just a minute. Do you want to bring it back for her? There we go. Oh, wrong one. Sorry. Jerry, Kimmy. There we go. Jazz. Yaren. Tristan L.
Oh, these
Oh,
are
whoops. There we go. There we go.
mine.
Yeah. Tristan. Oscar. Tristan's getting yours, Oscar. Tiana. Arthur. Taiki.
Thank you.
Oops, Jazz, I have one more for you. I'm sorry.
Are we allowed to read it?
Yes, absolutely. You'll take version B.
So like, so for number 1,
Yep.
do I just like combine lithium and fluoride?
Yeah, so you just say lithium fluoride and that's it. Pretty nice, right? Yeah.
Like,
Olivia. Awani. Fernando.
That's it.
Fernando. Oliver. Gavin. Taiki. Sorry, I didn't manage to pair yours off there, Taiki. Ella.
am I supposed to have this back in?
Nope, you keep it. Ella. Gavin. Tristan K.
Oh my god.
Angela. Abby. Evelyn.
There's still no 3B.
Go use the 3D. Evelyn. Brian. Gavin. Carissa.